Okay, let's talk about finding total surface area of things with curves, cylinders, cones, spheres, stuff that isn't prisms, in other words. Okay, so let's start off with the easiest of them, the cylinder. So when we think about cylinders, we really need to consider the shapes that we have in a cylinder. Even though it's three-dimensional, we really have some circles, and we have, well, it's a curved rectangle that's wrapped around the outside of the circles. So when we break it down, when we get the net of this shape, like I've drawn, all flattened, like if you were to make a cylinder out of a piece of paper, you would need this net to be able to cut it and then shape it. With this, all we really need to do then is to find the area of each of those component parts, the bits that make it up. So we would need to find the area of the circle. That's pretty easy. We know that there's pi r squared to give you the area of the circle. Don't forget that there's two of them though. There's a circle on the bottom as well as the circle on the top. The only other thing that we would need is the area of that rectangle, that curved section. We know that the area of a rectangle is just length times width. Now in this, well, we know that the width is the height, right? So back on our here, the height of the cylinder is the height of our rectangle. That's normally the width, and then the length, the longer part, although it doesn't have to be longer, it depends on the cylinder. That distance really is equal to the circumference of the circles, right? Because the distance from here all the way to the other side can be wrapped around the outside of that circle. So the distance for the length is really equal to the circumference of the circle, which is 2 pi r. So the area of that rectangle then will be 2 pi r times the height, the h. Okay, so we can put that all together then into the rule for finding total surface area, and it is, well, don't forget we had two faces, so it's 2 pi r squared plus 2 pi r h. And don't forget, because we're doing area, your answer will be in some squared unit, whatever unit that may be. Okay, so that's finding cylinders. The next one is the cone. Now the cone is a bit of a tricky one. Again, it helps to think about the net. What does the net of this shape actually look like? Well, when we create the net, you'll see that we have a circle, the base, which just has a radius of r. And then we have this sector. Now, this sector is not a complete circle. It's part of a circle. We don't know how much of a circle. So what do we know about this circle, this sector? Well, we know that this part of the circumference of this sector is equal in length to the circumference of the radius of this small circle. Okay, so whenever we go to do the formula for the circumference, if we don't have a complete circle, we end up using partial circumference. So look, so normally circumference is equal to 2 pi r times whatever percent of the circle. If we've got, I don't know, 120% of a circle maybe. But here that's not going to really work for us because we don't know the percent of the circle. All we really have is the fact that we have a distance. I can get rid of all of that. All we really have is the distance of the arc around the outside of the sector is equivalent to this circumference of our circle. So what we can say is that the circumference of the circle really is that. We could say that it's 2 pi r, which is the circumference of the circle, and it's divided by the total as if this sector was a complete circle. So we can then cancel out the pi and the r, the 2 and the pi on both the top and the bottom, and we get that the circumference of the sector is really equal to the radius of the small circle divided by the sector of the large one. Okay, so what do we do with that then? Well, we can then apply this and figure out the area of the sector. So the area of the sector will then be equal to the circumference of the sector, which we just figured out, multiplied by pi r squared. But r, in this case, remember that the radius of the sector actually was an s. That's why it's pi s squared. So the area of the sector is the circumference of the sector, the arc, and it's multiplied by pi s squared. Now the s down the bottom will cancel out the squared part. It'll divide into one of the s's here, and we're just left with pi rs. We already knew that the area of a circle is just pi r squared. So when we put this whole thing together, the total surface area will be equal to the area of the sector plus the area of the circle. So we know that it's pi rs for the area of the sector, pi r squared for the area of the circle. You could use that as the formula, that's fine, or we could take out the common factors, pi and r, put them outside of a set of brackets. We have pi r outside of s plus r, and that will give you the total surface area of a cone. Okay, one last curved shape that we'll talk about, and that will be, here's my two-dimensional representation of a three-dimensional shape, my sphere. Okay, I'll give you straight up the total surface area formula. Hang on, let me make sure that you can actually see that on the screen. So the total surface area formula for a sphere is 4 pi r squared. I can explain to you how we get that formula, and I'll do so underneath, but you don't have to know why. That's the important thing, is just to be able to know it. You have to know this formula and be able to use it. You don't really have to know why it works, but I can explain that anyway. Here we go. Imagine that we had our sphere, okay? We have our sphere and we stick our thumbs into either pole of the sphere, and we poke a little hole without deforming the circle too much, and we actually spread out the poles so that it ends up looking like a cylinder, right? And it's an interesting cylinder in that because we put a hole in the top and the bottom and stretched it out, we didn't want to make the height of the cylinder any more than the height of the normal circle, so the sphere. So the sphere is still 2r high. It just has been stretched out at the top and the bottom. Now it's not a cylinder with any circle there, it's just empty. It's a hollow kind of tube because we've stretched out our sphere. So if we do that and then split the sphere and straighten it out, we are going to end up with a rectangle, basically, because that's all it was. It was like a tube. If we look at the distances of the height of this rectangle, well, the height, because the sphere didn't actually change dimension in terms of how much height it was, it's still just 2 pi. But the circumference of the sphere around its equator is equivalent to 2 pi r. Now, because we have a rectangle, we can just find the area, the length times the width. So it'll be the length, the 2 pi r, multiplied by the 2r, and when you multiply that, the 2 multiplied by 2 gives you 4. There's our pi, and r times r is r squared. So yeah, the total surface area of a sphere is equivalent to 4 pi r squared. So that's our most common shapes that end up with curves. So that's what we learned how to do today, to find the total surface area of those.